All right, welcome back. And as you can see, we have on the screen here part of the Boschkovich force curve. This is actually the nuclear force, and this diagram is taken from Wikipedia in the article entitled Nuclear Force. What this represents is the relationship between two particles at their closest range. So this is quite a significant diagram. In one context, this has been called the strong force. The definition of the strong force was altered, essentially through the work that centered, I suppose you could say, on the work of a man named Gell-Mann, who discovered the quark system, essentially. Although many minds are involved at this level in discovering something. And the quark system is definitely a real mathematical system, which you could construe as a contradiction, although mathematicians don't, and they have a right to their view, because mathematics is so powerful. Now, what this graph shows is a curve. It's rather a simple curve if you know enough about curves to distinguish one curve from another. The simplest curve is the circle, because the rate that's being expressed by this object is a rate between the x and the y aspects. And that rate, when it's perfect, is a circle. So that's an interesting object, and the circle has always fascinated mankind. What you see on the screen here, over to the left, is not a circle, but in its own way, it is a perfect curve. And this is as I claim, a profound diagram, and I wish to explain to you so that you actually see it, so you won't have to believe anything I say. You'll simply see for yourself what is here. There are two infinities here, and using the pointer, as I trust you can see here, here is one part of the curve, and here is another part of the curve. So you can tell that there are actually two curves here which have a relationship. This curve is a long, rather symmetrical curve, but this one does not appear to be symmetrical going up. Not in the same way that this curve expresses itself in the graph. This curve does not have the same shape as this curve, which essentially begins at the nadir, which, if you can read the hatch marks on the x-axis, this is 1 femtometer, almost exactly. But this nadir, which is the lowest point of the curved line, is an expression of negative force. It's not spatial, and the proton does not exist on this line. The proton, which is conceived to exist on this line, and what is this line? It is the line that proceeds from this 0 point, which is actually a double zero, as you can confirm. It is the zero of the y-axis, which in Boschkovich's language was the ordinate, but this x-axis is the abscissa, and it's the zero of the abscissa and the zero of the ordinate simultaneously. And I hope you make a mental note that I did use the word simultaneous, which is not a spatial concept. It's a temporal concept. So this is potentially a profound diagram, but in order to see the profundity, certain explicit features of the graph must be brought out explicitly. So I introduce you to those features of this graph at this time. You have one curve that comes down from the right to the left and achieves a nadir. After that, proceeding from right to left, there's an abrupt curve, which then goes very you could say rapidly upwards. But what do you mean by rapidly? To the proportion that this curve stretches out to what actually is linear spatial infinity. It's the infinity of this line. This line, which is space, and it's the only spatial aspect of this graph, goes from the zero, which would be conceived as the frame of reference or the center, and from there, which is the center of a proton. That's very important. It should be borne in mind at all times that this 0, 0 point is the geometric center of a particle. What is on this line is conceived to be an identical particle. And the nature of the curve is the expression of the force relation between those two particles. And the force relation is obviously binary, because there is an above the line and there is a below the line, neither of which is a spatial area. The area of this 2D projection is expressive of force relation, and it should be said force relation, because there are two forces being expressed here, and Ruđer Josip Bošković discovered that. This graph merely confirms what he discovered, that when two protons are in close proximity, for the first, what you might call the half of this graph, where it's sloping downward, that expresses a certain relationship between the two protons that has a linear expression, and that would be spatial, and that's called linear spatial separation, which is the exact name of the metric of the horizontal line, which has its origin, which is its distance origin, at the necessary numeric value of 0 to begin the expression of distance. So this horizontal line is distance. It's the distance between the centers of the two protons, and it's very important to say they're centers, because protons, actually, by analyzing this graph, you will be able to see, as I will show you, that the two protons are not points. They have, each of them, the same radius. So they're exactly equivalent particles. All protons are the same, and that's profound. The profundity of that statement has not been fully appreciated, but I will simply point out to you a fact that protons are countable objects, because each one of them has a position, and that position is defined on its radius, and that radius cannot be anything other than what we must now define that is. And what it is expressed by this graph. This shows the radius of a proton. Where is that radius? I will show you with a pointer. It's right here, where the curved line makes its only contact with space. So the only intersection of force with space depicted on this diagram, which is a projection downward from a higher space, which I discovered, called spherical space, although it's known, I discovered it algebraically and geometrically, and you're looking at my discovery, which has been discovered in several ways by several other interested parties, but the way I discovered it was absolutely unique. So I'm expressing to you the uniqueness of this geometric insight, where your insight will begin with a recognition that the horizontal aspect of this curve is its primary aspect, because it's asymptotic with linear infinity. So this curve shows the relationship between force and space to linear spatial infinity, which means that the relationship between force and any two particles measured from 0, where one particle is at 0 and the other particle is anywhere on this line, this blue line shows the force relation between them, where this line as it approaches the horizontal space line, it approaches space. It never touches it. And that's infinity. That's the definition of infinity, which now needs a corresponding definition because that's an incomplete infinity. So linear infinity, as you might guess, since it's simply a straight line, does that really have an infinity? Yes, but it's embedded in a higher space which has a more natural infinity, and that's what I'll be showing you. So this curve is not the same as this curve, but what I'm going to be showing you is that they're perpendicular. These are perpendicular curves, and you can actually see that, and I will now point it out to you as I trace, going in the opposite direction of the path that we want the proton to head towards the other proton to see what happens. When one proton gets as close as it can to another proton, you can see from this graph the force relation between them at any point on the horizontal line. And the way you can read that is when you read the distance, which is on the horizontal line, because that's space itself, then all you have to do is measure that distance, which from here at 0 to where the blue line intersects, you simply read down. And it doesn't have to be down, you could also read up if you have the hatch marks, but you need to read the horizontal aspect, and you do that from the x-axis. And that's down here, where it's about 0.8 femtometers, because this is 1 where the pointer is, and this is 1/2. All right, so between 1 femtometer and 1/2 a femtometer is where this curve is moving. I'll just say moving because it actually is an expression of motion. And we'll see that in a moment. But the first thing I want you to see is that if a proton is at the extreme right edge of this diagram, then where the pointer is now tells you in the vertical aspect the amount of force between the two protons. And in this case, you have to be very specific about what you mean by force, because there are two ways to interpret this graph. Is this repulsive force down here? And above the space line is attractive force? Or is it the other way around? And this is attractive force, and this vertical aspect is proceeding upwards very, very strongly through the upper part that's above the space line. Is that attraction or repulsion? Because if this is attraction, it's above the line, really confined to this vertical aspect. There's no other part of the line, the blue line, there's no other part of the curve that's above the space line, where the space line is drawn explicitly to divide the two forces one from the other. And they're two opposite forces. One is repulsion and one is attraction. So if you can conceive that in your mind, as I hope you will try to do, because that will provide you the key to this graph, then below the line will be one of those two forces, either attraction or repulsion. But whatever you decide, that will decide also what is above the space line, which will be the opposite of that, either repulsion or attraction. So which is it? That is one of the most interesting questions that I have ever faced in my scientific career, is to answer that question. Which is which? I can tell you what Wikipedia says, but you may want to guess first. This is two protons, which have a charge relationship that drives them from each other. But this is a graph of what happens when they're close enough that that repulsion changes to its opposite. So if this is two protons, then the natural force between them will be repulsion. Correct? Because they're both positive, according to the Coulomb force construction, which has been demonstrated certainly to be accurate as far as we can tell, that you can conceive of these two forces as having an opposite, as expressing an opposite charge. But that's not actually what this is. Because if it were the charge relationship, it would be the charge relationship between the proton and the electron. And you've already seen that that is the Boshkovich force curve, which is a multiple curve, which needs to be there. That is multiple curves, whereas this is a single curve with respect to the Boshkovich force curve. It's because when you have electrons, you may have more than one shell. But when you have protons, you need to be specific on what is binding with what, because there can be up to 100 stable protons in one nucleus. So this is called the nuclear force, because it is what binds charged nucleons together. And a charged nucleon is simply a proton. And the proton is one state of a two-state particle, where the other state of the proton has no charge, which is an interesting change of state. And the proton will change into a neutron, although that is called beta decay in general. There's more to it. But the opposite, a neutron changing into a proton, is actually natural. So the proton is the more natural of the two objects. But neutrons are scarcely less natural. There is such a thing as a neutron. But the neutron and the proton, when they're measured, are almost exactly the same, with the exception of the charge. So it could be said, just perhaps hypothetically, as I do say, I believe this is the most natural interpretation, since they are both nucleons, and they have exactly the same weight with a minutely fractional difference. They're almost exactly the same. I believe they are the same except for the charge, but that would need to be proved. That's simply a hypothesis, which I don't promote that at this moment. But that is what you're seeing here, is not the electrostatic relationship, which is specifically the relationship between the electron and the proton, where the electron is attracted to the proton. The electron is attracted to the proton. So if this were the diagram of a hydrogen ion coming into existence into an atom, where there are two ions, one's an electron way over here, and that would be at the extreme right of this diagram. I sincerely hope that I'm not confusing you, but I cannot slow down. Rewind this if you need to listen to this again. But I just rather abruptly switched from what is here traditionally called the strong force between two protons, which are plus-plus relation. But if this were interpreted, as it certainly can be, this is part of the Boshkovich force curve, which actually describes the relationship between the proton and the electron, although remarkably to say, Boshkovich was unaware that there were two particles involved. So he came up with the exact diagram of the Bohr atom without knowing that it involved a charge relationship, which is a remarkable thing to say, because he got the exact same force curve without considering the charge. How did he do that? I know the answer, and that's what you're going to learn. But this curve is so simple that it's remarkably simple, and I wish to point out to you that the simplest way to describe this, if you know what you're talking about, is its two perpendicular curves. And let me show that to you. But before I do, I want to finish my thought, because this is the force curve of the proton-electron-hydrogen atom, which is redundant. Hydrogen is defined on this curve. This is the curve of the relationship between one electron and one proton, but based on their attractive force, so that the dip coming in from the right to the left, the dip is attraction if this is the proton-electron relationship. And this is the correct curve for that, for one proton, which is at the 0, 0 point, and the electron, which is conceived as approaching the proton from right to left on the spaceline. The electron will only be on the spaceline. It is never above or below the line physically. The only physical aspect of this, although that's an interesting use of the word physical, the only spatial aspect of this would be the right word there. The only spatial aspect of this is the horizontal line, not above or below it. The above and the below shows the relationship between space, which is the separation between the two particles, on that line. That's the linear separation between the electron, conceived as its center, and the proton, which is stationary. That is, it is the inertial frame of reference in this graph at the 0, 0 point on this 2D projection. There's a proton there, which does have a radius, and this graph proves that it does have a radius with respect to the electron. So if there's one electron and one proton, and they're at some distance from each other, this graph shows the force that exists between them, which is conceived as a polaric force. It's plus or minus, and that's shown on the vertical aspect. Above the line will be repulsive force, and that's the basis of the Bošković natural theory of philosophy. The philosophical basis of physics is defined here so that it matches reality. That's very important. But it is a very interesting conclusion that he reached, that this curve goes beyond Newton. What Bošković discovered from this curve, what he proved, and he explicitly proved this, is that he went beyond Newton, where Newton had defined essentially centripetal force. He was an expert on gravity. What Bošković elaborated, really extending what Newton discovered. What Newton discovered, he was only able to formulate into an attraction system. And that's commonly admitted. I've checked several authoritative sources. That is the correct evaluation of what Newton discovered. He discovered attractive force, but he never integrated the necessary counterforce, which is a remarkable thing to say about Newton, because he was the one who came up with the proved theorem that for every action, there's an equal and opposite reaction. Well, in the case of his theory of gravity, he never accounted for the equal and opposite action of gravity, which is a force, which has been argued. And Dr. Sabine Hossenfelder of Deutschland argues very strongly that that's not a force, and she definitely has a reasonable basis for saying so. It's just a question of if that is the correct reasonable basis. It is superpositional, and we'll circle back to that again. I keep bringing up superposition because it keeps coming up, and it's so explanatory that you're going to like superposition just as much as you like what you're going to learn from this graph now, which is what? There are two perpendicular infinities. That is so profound, I hope you just pause and meditate on that for a moment. You can always pause your video. I know you have that button. So, are these two infinities perpendicular? Can you identify the infinities, and can we define what an infinity is? All of these are excellent questions. And the answer is on this graph. But it requires interpretation in order to get the meaning. What does it mean that this part of the curve is asymptotic to a vertical straight line, to the proportion that this curve is asymptotic to the space line. That means that this part of the force line is describing an attenuation of force to infinity where it never achieves zero. It never actually is absent. In other words, those two particles, the electron and the proton, no matter how far separated they are, this graph, this part of the graph proves that no matter how far apart they are, there will never be zero force. And that is so profound, it goes to the heart of mathematics, and I'll be showing you that. So there is one part of the dual infinity, but this is not polaric dual. This is asymptotic, that is the force. The decreasing force of attraction between an electron and a proton is depicted on this part of the graph to infinity, that it never achieves zero. This blue line never intersects. This is a form of parallelity, but it involves Zeno's paradox. I hope you can appreciate what I'm saying. This is highly integrative. This solves a lot of paradoxes. And I wish to explicate that for you in some simple sense, so you appreciate what you're seeing here. This is the curve of the relation of force to proximity, such that the distance between the two objects, in this case, in my example, is the electron and the proton, such that this dip is indicative of acceleration. But when it gets close enough, the acceleration abruptly stops. This is the cessation of acceleration. But the velocity continues, but it's not very much. The velocity is not going up greatly. I'm sorry, the velocity is going up. What is not going up is the distance between the two objects. So that what you're seeing here is the deceleration of the electron. So the electron is coming in at a low velocity and it's accelerating. As it gets closer to the proton, it's accelerating, and here is a tipping point. And now this is a very steep increase in velocity. It's accelerating. It's accelerating to maximum velocity. And if this curve did not change orientation, if it kept going off the bottom, it would go the opposite of this. If this were extended, this can be shown algebraically, that if this curve continues naturally without a change, it would not execute this really violent shift, because this is acceleration and down here is maximum acceleration. That's not the same as velocity, as you know. Acceleration is the progressive increase in velocity. It's an additional velocity to the velocity that already exists. So the velocity that exists here, which is expressed as a potential if this is a static graph, but if it's showing motion, the motion is only along this line. This blue line does not show motion. What it shows is the relationship to the position up here in space with the actual force at that proximity. And that's a mouthful. And I wouldn't blame you. Rewind this, because I have been practicing to say this correctly. I can hear myself. And I know that what I just told you is true. So if this confuses you in any way, rewind this and listen to it again. This is a force line which in its horizontal aspect is referring to spatial position. But this in itself is not spatial position. It's the actual force involved. which is between the two particles. So if the electron is here, it would be here on the spaceline. You read down, and so at about a little over 1 femtometer, when the electron is 1 femtometer from the proton, its acceleration is maximum. But if you read it statically, that is, the electron has no velocity, what it says is that at that point, if you started action with the electron just say temporarily frozen at that position, that's where it is with relation to the proton, and you start action, what you can read from the blue line is what would happen. And if you started action with the electron without any actual velocity, in other words, it's another inertial frame of reference, if it's on that spaceline at 1 femtometer, without its own velocity, it's just in an inertial frame of reference. And so both of the particles are inertial. So there's no velocity attached to either one. That's what that means. If you read it that way, it's called the static representation of the graph. What it means is that when you see the electron at that position at 1 femtometer from the proton, that the electron can be predicted precisely, absolutely, what its relative force relationship is with the proton. And what that means is that if there really were no velocity attached to either center, the electron or the proton, and you started action and saw what could happen, that the electron would immediately begin to accelerate towards the proton at its maximum speed, which is a bit difficult to define. What would that be? It would be according to the force metric on the vertical aspect, which is marked, and I don't believe you can read that. And I'll just expand this just a little so you can read. What is the metric of the vertical aspect? It's force in the 4th power of newtons, the 4th decimal power of newtons, which is a force unit. So it's force. But which force? Because there are two opposite forces, and Bošković discovered this. This is part of the Bošković force curve. It just so happens that it's also prominently displayed in the Wikipedia article on nuclear force, because this is the exact same curve between two protons at close proximity as between an electron and a proton at close proximity, except with the force valence, that is attraction and repulsion above and below the line, reversed. And that's profound, because that's a remarkable identity, that it's the same force curve at closest range. This is the force curve depending on if above the line is attraction or above the line is repulsion. If above the line is repulsion, then this is the proton-electron relationship at the inner shell of an atom. But if the above the line is attraction, and this may sound strange, and this is the hardest thing I've ever had to say, it's in a way the strong force. And that's the limit of my knowledge, which goes well beyond what physics actually knows at this point. But it's not the end. This goes on and on and on. But on the way to go on and on and on, we're going to get the solution to every single problem that faces physics today, including in astrophysics. So I hope you stay tuned for that. That's 35 minutes. It's probably a good time for me to take a break. I'm anxious to get all of this information out, and I told you that it will be condensed information from now on. I have elaborated on everything I'm saying in hundreds upon hundreds upon hundreds of videos. Actually, 1,400 videos to date after 3.5 years of work producing these videos. I'm summarizing what I've learned, which has continued over that entire period. So this is a progressive synthesis that is not by any means exhausted, and that is the nature of science. However, we've reached a complete watershed, a complete changeover, because now we can, and actually must, leave behind the nightmare of linear algebra. It's absolutely nightmarish. So this is a very welcome discovery for everyone involved with science, because no longer will we have to go through the nightmare of calculus, or the nightmare of complex numbers, or indeed the same nightmare that defeated the Pythagoreans and the entire Greek culture. They could not figure out the number system for the circle. I figured it out. Stay tuned. We'll be back over the next few days as we approach the new moon, which is within this week. I will be becoming increasingly religious. I'm an extraordinarily religious man. It's just a coincidence that heaven gave me the secrets of the universe in physics. I don't ultimately care about that, except that it expresses the beauty that I happen to know a lot about, which I'm more anxious to share with you than anything in mathematics. But this is the right way to get at it, and we're programmed to do this, so I am on the way of heaven as I pray before my benefactor, who brings to me, and I hope to you, these insights which I will be unfolding to you over the next 2 days, over 6 to 8 hours of lecture, which will be extremely demanding on you. Don't forget, you're going to surpass every scientist who has ever lived. There is no question about that, and I give you my word on that as a man, as a reputable scientist, which I trust I am before the Almighty. May His name be praised forever. We're approaching the Holy Sabbath. Keep looking up, and we'll be right back. Thank you so much for tuning in. And for those of you who have asked questions, my heart is soaring like a hawk. No matter how much I may sound like I'm criticizing you, I think you understand what we're both doing now, and you are now enlisted. May Allah protect and guide you at all times with His wisdom and love, and you'll make it. I did. But nobody knows for sure. I just say that because my heart tells me I've made it. It's not my decision. But I trust in my Creator. He's merciful and compassionate. As all Islam people begin their prayers each time they pray, I do too now. That makes sense to me. In the name of God, the merciful, the compassionate, may your house be blessed always. Stay tuned. We'll be right back.
And I mean that kindly. We're all idiots in the eyes of the universe.